Hi everyone. Today's lesson is about exponent laws. The first law we're going to look at is multiplying exponents. You might recognize this chart from a previous lesson we had. So let's look at what the question is asking us. So it's giving us product of powers. So we're multiplying 2 cubed by 2 exponent 4. Now, let's write that as repeated multiplication. So we have 2 multiplied by 2 multiplied by 2 multiplied by 2 times 2 times 2 times 2. Next thing we're going to do is we're going to count those all up. We've got 1, 2, 3, 4, 5, 6, 7. So we know it's been multiplied by itself 7 times. So 2, which is 3 plus 4, equals 2 exponent 7. That's interesting. Let's have a look at another example. In this one, we know that our base is -2, so we're going to write that out in repeated multiplication. We have 2 of them, multiplied by 1 more, which gives us a total of -2. And don't forget your brackets here. Those are important to keep that negative with the 2. And we have 3 in total. So remember over here, if we don't have an exponent, we can assume, or we know, that the exponent is 1. So again, what we did is we added the exponents. The big takeaway from this is that when we are multiplying exponents with the same base, we need to add the exponents, which gives us the general rule that when we multiply powers with the same base, we add the exponents. Next, we're going to look at dividing exponents. When we're dividing exponents, we can set it up like a fraction. So in the numerator here, we have 7 multiplied by 7 by 7 by 7 by 7, which gives us our 7 exponent 5. And then we're going to divide by 7 squared, which is 7 multiplied by 7. Another thing we know is that any number over itself gives us 1. So we have 1 group, 2 groups of 1, which leaves us with 7 exponent 3. And what you'll notice is that we're actually subtracting. 5 subtract 2 will give us 7 exponent 3. Let's have a look at another one. So we have a base of -2, and we have 4 of those. Okay, divided by 2 more -2's. And here you'll see we have 2 groups of 1, leaving us with 2 -2's. And we can show that, again, by subtracting our exponents. Which gives us a final answer of -2 exponent 2. The takeaway from these examples are that anytime we're dividing exponents with the same base, we subtract the exponents. To simplify that expression. Power of a power. To explore power of power, we're going to already look at what we know. So in this first example here, we have 2 cubed with an exponent of 2. So the first thing we're going to do is we're going to write out that squared unit. So our base is 2 cubed multiplied by 2 cubed because we have 2 of those as indicated by the exponent of 2. Next, we're going to expand each of those. So we have 2 multiplied by 2 multiplied by 2, which is multiplied by 2 by 2 by 2. So in the end, we'll have 2 exponent 6. Now, if we look back and we look at those exponents, the 3 and the 2, what operation do we have to do to end up with a final answer of 6? If you guessed multiplication, you are correct. Now, let's have a look at our next example. So in this one, we have negative 4 squared cubed. So we have negative 4 squared 3 times. Okay, so that's our first expanded form. Next, we're going to expand each of those squares. So negative 4 multiplied by negative 4, and we're going to do that again. And let's see if we were right when we predicted that we multiply our exponents. So we have 2 multiplied by 3, that gives us 6. And 1, 2, 3, 4, 5, 6, we do have 6. So negative 4 exponent 6 will be your power form. So the rule here is that anytime we have a power of a power, so a power of a power will look like a with an exponent here and another one here, we multiply the exponents. In this section of the video, we're going to look at power of a product. Let's have a look at a couple of examples and write them in expanded form to help us get a better understanding. So in our first example, we have 3 multiplied by 2 squared. So the first thing we're going to do is write out our squared units, and that's just whatever is inside those brackets multiplied by itself. Okay, and now we're going to rearrange those factors. So we have 3 multiplied by 3 multiplied by 2 multiplied by 2. And here you'll notice simplifying just means rearranging. So I move my 3 from here and here, and then I move my 2's. So all those factors are there, they're just in a different order so that it's easier to see that we have 3 squared and 2 squared. 3 squared multiplied by 2 squared. Let's have a look at our next example. Again, we're going to square whatever's inside those brackets. So we have a negative 4 cubed multiplied by 3 squared multiplied by negative 4 cubed times 3 squared. Now that we have those written in, we're going to rearrange those. So we have negative 4 cubed multiplied by negative 4 cubed multiplied by 3 squared multiplied by 3 squared. And we're going to simplify that by applying our multiplication rules with our same basis. So if we're multiplying negative 4 cubed by negative 4 cubed, we're going to end up with negative 4. And remember, we add those to the power of 6. And I'll write it here as well. And 3, and we have 2 plus 2, which is 4, times 3 to the power of 4 to give us a final answer. And the general rule we can take from here is that anytime we have a power of a product, the exponent gets applied to both of the terms we're multiplying. Now we're going to review power of a quotient. Let's have a look at a couple of examples to help develop our rule. When we have power of a quotient, it'll look like our examples do over here. The first thing we'll do is we'll write it out in expanded form 1. So here we have 2/3 cubed. So that will be 2/3 multiplied by 2/3 multiplied by 2/3. which gives us 2 multiplied by 2 multiplied by 2 all over 3 multiplied by 3 multiplied by 3. And that gives us a power form of 2 cubed over 3 cubed. For our next example, again, we're going to do exactly what it tells us. So we have 2 cubed over, or divided by 5 squared 4 times. So we'll start by writing the 2 cubed, 5 squared, and we have 4 of those. And next we'll put it in expanded form 2, where we simplify those. So we have 2 cubed multiplied by 2 cubed. Okay, all over, or divided by 5 squared multiplied by 5 squared. Okay, we can apply our multiplication law. So we end up with 2, 3, 6, 9, with an exponent of 12, 5 exponent 8. Let's have a closer look at what's happening here. In our first example, we have 2 with an exponent 1, because it's not written there, so we know it's a 1. 3 exponent 1 with an exponent of 3. Okay, and what we're going to do is we're going to multiply those exponents here to this one and to this one, just like we did with power over power, exactly the same. So we have 2 exponent 3, 3 exponent 3. Now let's see if it works in our other example. 2 exponent 3 over 5 exponent 2, all exponent of 4. And again, we're going to do that multiplication here and here. So we have 2, 3 multiplied by 4 over 5 with an exponent of 2 multiplied by 4. Give us a final answer of 212 and 5 exponent 8. So the general rule we can take away here is that when we're finding the power of a quotient, the power gets applied to both terms in the equation. Which can be written like A over N, okay, is equal to AK over N exponent.